Hello and welcome to Tuesday Talks at Mary Spring Nature Center for 2026. My name is John Fromer, the Program Director and your host. Today's Tuesday Talk is generously sponsored by Camden River House. Recordings are made possible by the Cascade Foundation. You can find today's talk and previous talks on our YouTube channel. Mary Spring is open every day of the year from dawn to dusk free of charge. Find out more at maryspring.org. Today's talk on the Interactive Climate Solutions Simulator is presented by Paul Stancioff.
Okay, well, thank you, John, for inviting me. Thank you, Mary Spring, and welcome to the audience, our 3 live guests, as well as a few online. As John said, I'm Paul Stancioff. I retired physics teacher at University of Maine Farmington, done a number of stuff with energy education related stuff. And so I'm here today to talk about this program called En-ROADS, which is get into some details. This is the interface of En-ROADS with the, that I have on the screen here currently, and I'm going to spend a few minutes giving you a quick tour of what it is and what this screen represents. And then after the introductions of explaining a little bit about En-ROADS, I'm going to ask the audience for suggestions on what you might consider doing as a policy to have an impact on what the climate issue. Okay, so what we're going to be doing essentially is seeing if we can come up with policies that reduce the increase in temperature over the next, to the end of the century, to under 1.5 degrees ideally, or at least to the point where it's down to 2 degrees above. These are degrees Celsius, by the way. 2 degrees below, or from 3.3 here to 2 degrees. To avoid some of the more disastrous particular consequences of global temperature increase. So what is En-ROADS? This is what it looks like. Well, what's behind this screen is a very complex model that shows the interaction of climate with economics, with all sorts of things. In fact, if you want to see sort of a very course level flow chart, it might look like, oh yeah, there it is. There's a little bit of a lag of this. You don't need to look at the details here, but it really just shows the interaction, the impacts of climate with energy demand, energy supply, emissions, agriculture, all of these things. And it's literally something like 20,000 equations that are behind this that were put together by a collaboration between MIT Sloan School and a group called Ventana Systems, and they formed a nonprofit called Climate Interactive, and they've been working on this program for a number of years, and they keep modifying it to sort of make it, tweaking it basically. And what it does is it simulates the impact of policies that would have an impact on greenhouse gas emissions, and the impact of that is global temperature increase. It's how do I want to say this? Global climate model. It doesn't go into details of like, what if the U.S. suddenly stops burning coal? It's a policy simulator. It's not a like we can't play God with these production of greenhouse gases. We have to play politicians and policymakers. So let me just give you a quick overview here, and then we can get into the workings of it. What we see on the display here are, should I use my pointer on my screen or my hand up here?
Whichever you like.
Okay. Is a couple of graphs up here, and then a bunch of sliders down here. So I'm not going to argue about the fact that our temperature increases are due to increased greenhouse gas emissions. That science for that is all settled. So our biggest concern is how do we control our greenhouse gas emissions to lessen the impact of this temperature increase, or to reduce the temperature increase. Since about 80% of our greenhouse gases are coming from the use of fossil fuels, mostly for and almost exclusively for energy, then the obvious thing to focus on and prioritize is energy use. But there are other sources of greenhouse gases that also need to be considered. So just an overview here. The graph here on the left is sources of primary energy that the world uses. And so it includes coal, oil, gas, renewables. You can see that it's all color-coded here. Bioenergy, the pink up here. Nuclear, the thin blue line up here. And then there's a thing called New Zero, which simply stands for some breakthroughs in technology, like maybe fusion electricity, or some magical flux capacitor invention that produces energy from nothing. And it doesn't show up on here because it hasn't happened yet. So this is up until current time, 2025, 26. This is basically historical use, but beyond that, these are the projections based on our current trajectory, like with no policy changes. On the right, we have a graph. This currently is the graph I have put up here is greenhouse gas net emissions. Again, historical up until now, and then projections up until 2100. And then all the way to the right, we have the projected temperature increase. I can change any of these graphs. There's a whole bunch of different graphs that I could put up here, and I'll be showing you various different ones. Sea level rise, for example, just a graphic of sea level rise. But a whole bunch of other things. The temperature change until the end of the century, I could put up there as well. So this is a graph of temperature change over time. And you can see here that it's fairly steadily increasing line. And so that's an issue. We want to try to bend the curve on that. Okay, how are we going to do that? Well, below the two graphs here, we have a bunch of sliders. This left-hand group of sliders over here are about energy supply. So there are ways to control coal, renewables, oil, nuclear, natural gas, this New Zero thing that we're going to invent next year, bioenergy. And then under that same category is carbon pricing, because that has a direct impact on the use of fossil fuels. And so we'll be looking at that as well. Then this middle column here, transport and buildings and industry and growth, are basically the demand side of energy. So obviously if you drive, you're using energy. If you heat buildings, if you manufacture things, you're using energy. So everything requires energy. Our entire society is heavily dependent on energy. Our production of everything is very closely tied to energy usage. And included in this group is economic growth, because again that affects demand. In fact, historically there's a very strong correlation between economic growth and energy usage. As well as population, of course, more population, the more demand. So that's the demand side. And then all the way over to the right, we have other sources of greenhouse gases, miscellaneous other things that includes agricultural emissions, waste, deforestation, and also, according to more recent projections, we're probably going to need, if we want to do what we need to do, we'll need ways of actively removing carbon dioxide from the atmosphere. And so we'll get into that. Okay, so that's an overview of this. Let me just give you a quick sense of what it means to move one of these sliders. And I'll go over here to the coal as an example. So the idea here is when I change a policy, the model predicts or projects. I don't like to say predict because predictions are always difficult, especially when they're about the future. But projections based on these modeling of what will happen to energy use, temperature, and all these other different things. So maybe you can probably guess what will happen if I subsidize coal. This slider can go either way. It can go to the left, which means putting some kind of a tax on coal, or it can move to the right, which would be adding more subsidies to coal. And so I'm just going to be, firm. I'm going to say I'm going to have a really strong policy against coal. And what will happen then? Well, coal usage, this dark brown line will decrease. Well, okay, yeah, it's decreasing. And it's making a small difference in the, you want me to go all the way over?
No, I'm saying I'm supposed to toggle back and forth.
I can do that, yeah. So I can go to extreme on coal or go back here, and basically you see the change that's happening. You see a slight drop in the temperature curve. I'm going to go back to the greenhouse gas graph here. What happens to this curve here? You get a slight drop in that. And you get a slight drop in the temperature at the end of the century. So that's just an obvious thing that, well, yeah, of course we got to stop burning coal because it's the biggest polluter. More CO2 per unit of energy than any other source. All right, so what I'm going to do now, though, is ask you, the audience, including online, if you're online, just put it in the chat when I'm going to, in answer to my query here. By the way, in the chat, there is a link to the En-ROADS program. Anybody can use this, and I encourage you to play with this as much as you like after the fact. And I didn't give John my email, but I would encourage anybody to email me as well. And we can put my email in the chat, I guess, as well at some point. You have my email, John. Can you put it in the chat?
Yes, it's on the slide. So the first one, what would a dramatic drop in population do?
Okay, that's okay. Let's. Are there more than one?
Just that for this moment.
Okay. Okay. Now, before I do that, first of all, we can't kill people off. So I don't have the power by policy to reduce the population from 8 billion, whatever it is right now, to 5. That would be. So you have to have policies that reduce population growth. So I'm going to push the population slider all the way to the left, which means at the smallest rate of population growth. And incidentally, each one of these sliders, you can see there's 3 dots here. You can go inside, and if I just move the slider, it just does the sort of the coarse level. If you click on these dots here, a piece comes up here which shows global population growth with status quo. And so what I'm going to do now is move this slider all the way to the left. But before I do that, I want to ask the audience, both the live audience in here and the online audience, how much change in temperature do you think would happen if I do as the strongest population growth policy I could? Do you think it'll be dramatic? Remember what we're trying to do in the end, we're trying to go from 3.3, which is what the current projection is, to down to 2 or below.
If you do a zero population growth, I bet it only comes down to about 3.0.
Okay, so down by 0.3 you're suggesting. Any suggestions online, guesses about how much temperature change is the maximal population?
And this is by when, temperature?
This is by the end of the century.
And
Right, so we're trying to bend that curve.
Yeah, if you're online, put what you think would happen to the temperature change in the chat. If you need to locate the chat, it's at the top of your Teams window on the left. One person said they guess almost no change.
Okay, and you said 0.3, Dan?
I'm just curious, can you explain why you're projecting it? Or why do you think it's zero? It's okay, I think
I just think it's gonna go down a little bit simply because of fewer people, less usage of energy, but it's not gonna have a tremendous impact.
Okay, so let's do that. I'm going to push it down all the way. And the reason I opened this sub window is because it shows you how much the population decrease actually is. And notice what it did to the temperature. This person online
100.
suggested a small amount. You suggested 0.3. It's 1/3 of that. It's not very much.
Right.
So I'm going to put that back because
and that's probably partly because the total population growth is expected to level off. Is that what they're saying?
yeah, I mean that's what all of the people that study population growth, the geographers and like are predicting that it's going to max out. A lot of reasons for that. I don't want to get into it, but yeah.
I guess it would depend on where the people are. If they're at the equator, they don't need heat.
Yeah, but they need stuff. They need
Air
supplies.
conditioning.
And it's also been shown that the higher the standard of living of a population, the slower the population growth rate. And so, it would behoove us to have a better standard of living worldwide. We use more energy per person that way, but we get a slower population growth rate.
So I read recently where China, the population growth there, or new babies or like that is down to about 1 per couple.
Right, they actually have an
And
issue.
it's not by
Okay. Moving on, do we have another suggestion for what might have a good positive impact on our temperature increase? Anybody online? Any other suggestions coming in?
Not yet.
Dan? Ben?
Can I propose that you ramp up both the renewables and the electrification of transport?
Okay. Both renewables and electrification of transport. I'm gonna do the electrification of transport first, just to see what happens. Any predictions on what will happen when I electrify transport all the way?
Does that include planes?
No planes, we don't really know how to do that yet, but they're gradually putting into this model hydrogen, which could eventually be a substitute for aviation fuel.
Can you define
Don't
the
get me into biofuels. Pardon?
Can you define the electrification a little bit more?
Well, in the case of transport, it simply means going over to more electric vehicles, fully electric
I see.
vehicles.
It's
Yeah.
not electricity transport, it's
Oh
transportation.
no, this is transportation.
Transportation,
actually.
yeah.
It's moving things around, it's shipping and driving and, trucks
Trains,
and cars,
etc.
trucks, trains.
Less
And-
fossil fuel, more batteries.
And so, how do you think this will affect what we're trying to do, reduce temperature increase?
If it reduces fossil fuel use, I presume it would drive the temperature increase down. We don't have any
Okay.
idea how much.
So I'm going to first electrify the transport.
Fully electrified.
Yeah, what do you think?
All the way across?
Sure.
John, what do you think for temperature change?
Well, it depends on how you're manufacturing all of that.
Mm-hmm.
And
It's gonna be very small, it's gonna be 0.2.
I'm gonna go for it, all the way. Oh my gosh, you see a slight dip there, but you don't see much change at all. Now, you have to be really careful with this model because I've done this before and somebody concludes, based on this one move, that electric cars don't matter. But if you look carefully, and notice, Dan, I didn't do your renewables increase. I'm going to go back to 0 here, to electrification, and slide it like that. If you look at, I'm going to change this graph to, sorry, primary energy demand. Instead of by area, I'm going to do a graph where it shows each individual energy source. And now I'm going to go to electrification. And if you watch, there's one line that goes up. Well, the renewables line, the green line goes up a little bit when I electrify, but there's another line that goes up. And that in here, the coal goes up. Because when you electrify cars and you don't do anything else, where are you going to get your electricity? Coal and gas both go up because they're used to generate electricity. They're not. Oil is the primary, is the fossil fuel that really takes the hit from electrification of transport. But gas and coal don't. They get a boost.
Because they're used in generation.
If I then increase renewables, yeah, that makes more difference. It goes down by 0.2 degrees more. So we're now moving. And that goes up. But if you look, I'm going to go back to this overall energy because, watch, there's things to notice here. I'm going to go back to this area graph. What happens when I increase renewables and I don't do anything else? And I increase electrification? You'll notice that the total energy used doesn't really change. In fact, it increases slightly as I increase renewables. Because instead of replacing fossil fuels, I'm just adding on to them.
Just my 0.2 degrees.
Yeah. So, back there. Okay.
online we have change in economic growth.
Okay. That's an interesting one because I'm going to do that one now. And I'm going to decrease economic growth. Again, I'm going to go to the sub-menu because then you can see the economic growth graph as I do this. And so GDP per person, I'm going to decrease it from long term from 1.5% per year down to a small number. And look what happens. Wow, that makes a big difference. What are the, I was going to say but something. What are the buts?
Politically impossible to do.
Politically impossible to do. It also, it means standard of living for people. You know, what's going to happen in third world countries. So that's an issue, but it does make a big difference. And so degrowth is a thing that people talk about. Degrowth in population also, but degrowth in economics. So that's an issue. And where does it take? It decreases everything, including renewables.
So if you change one thing, it automatically affects some of the other.
Absolutely.
Thanks. Okay.
I'm going to come back to this economic growth one in a little bit because things are interactive in the world and in this program and in the equations behind here, things interact. So changing one thing at one point will show a kind of change. Changing it when other things have already been changed, it's going to look different. It may look different. So we'll see that.
You go through a whole program, if we ask certain ones that we'd like to see, would you?
I want to keep asking you other ideas. Again, online people, I can't see the chat, so John has to tell me.
I would like to see what would be sort of like a call it a 50% decrease in agricultural emissions, what that effect would be.
Okay, yes. Let's look at agricultural emissions. I'm just going to move the slide here to see what happens here. Again, I'm doing these things one at a time and then going back to not nothing,
Yeah.
but small. And you can also see some of these curves. You can see the dip, but then it kind of trends back up again
Yeah, well, yeah.
over time.
Yeah.
And if you go into the details, the submenu on agricultural emissions, there's different things you can do. You can control how much methane. Again, these are policy changes. You can't just, turn the methane off coming out of a cow. You have to figure out policies that encourage whatever needs to be done to do these things. Cynthia?
How about energy efficiency? Like crank that up. I assume that means weatherization of buildings.
In buildings, yeah.
And
in transport, I didn't
and
even...
energy efficiency in industrial, is that what it is, in manufacturing or whatever? What is that?
Before I do that, I just remembered something I wanted to show. Yeah, I will get to that next. But when we were talking about electrification of transport, I want to show a graph here of transport, existing transport by carrier. What do that interferes? So this is the status quo, and I want you to notice something. This is fossil fuel-based cars, transport, I should say, and this is electrified transport. This is without any changes. What you're seeing is we're going to be electrifying anyway. In other words, we don't need incentives to electrify transport because it's better anyway, and people are discovering that. Look what's happening with the Chinese electric car manufacturers.
But does this include shipping and everything too in there?
I think it includes shipping in there as well. But I'm not sure what they're projecting specifically for the individual transportation modes. But if I notice what happens if I electrify vehicles, it changes when it gets electrified. But it doesn't change the fact that we're going to be electrifying most of our transport. Which is one of the reasons why that slider, moving it all the way over, doesn't make that much difference, because it's happening anyway. Which means electrification of transport is important, because if we just forget about it and ban it, for example, then... So now back to Cynthia's question, I want to make buildings more efficient. It's not just buildings. Buildings and industry efficiency includes increase in efficiency of manufacturing processes, because that uses a whole bunch of energy. But heating and cooling of buildings is also a big chunk of that. I don't know what the distribution is. That might be half and half, I'm not sure. So I'm going to increase building efficiency. And so I'm going to put that back to greenhouse gas emissions. And I'm going to increase building efficiency by a lot. I was supposed to ask you to make a prediction. That's a pretty good chunk, 0.3 degrees. It's one of the larger changes that we've seen so far. I'm going to go back to
You just changed the buildings and industry energy efficiency, right? That's it.
yeah, that was the building's energy efficiency. That made a big drop in total energy usage.
What's
That's-
energy efficiency in transport mean? What does that mean? Like just better miles per gallon in cars?
Yeah. It could be smaller cars, could be better, more efficient.
Well, can you add that too?
Yeah. Makes a difference. And electrify as well. That's maximal electrification. Again, that doesn't mean everything is electrified. It means our policies are pushing electrification as much as possible.
It didn't add anything.
It made very little difference. Okay.
And what are we trying to reach here anyway for temperature?
Below 2, at least, at a minimum, we want to get down to 2. Ideally, we want to get down to 1.5. If we get down to 1.5, basically, we're going to be sort of where we are today in terms of global temperature. It's about where we are now. We might overshoot, we might come back down.
Somebody has put in, the point is that it would take policies that are multifactorial if population and economic growth remain stable, status quo. So what happens if you put the carbon price all the way over? That's taxing carbon basically, right?
Okay, I'm going to get to that in a minute, but
Okay.
before I do that, a question that often comes up is, what about eliminating subsidies for fossil fuels, which we currently have? In other words, this slider right here for coal, oil, and natural gas, currently we have substantial subsidies for coal, oil, and natural gas, real subsidies. There are other sort of externalized subsidies that we don't account for, like the health impacts of pollution and that sort of thing.
And you're talking worldwide subsidies? For this?
Yeah, and I don't know the number exactly, but based on what I've been told by others that use this model, that if I slide these 3 just a little bit to the left, like right around there, and there, and there, they're going to put into the model more explicitly the subsidies. But they make a difference. Not a huge difference. I mean, I don't know what they said. Small difference, like 0.1 degrees Celsius. So I'm going to put those subsidies on here. Subsidies, remove the subsidies. And maybe add some subsidies to renewables. That doesn't seem to be doing much.
You have the energy efficiency and all maxed out as well.
Yeah, I do. So actually, I'm gonna put some of these back to their starting points because John, you just asked about carbon pricing, right? So I'm going to keep the subsidies removed, and now I'm going to actually put a price on carbon. What do you think the impact of carbon?
Well, what does that mean though? A price
Oh
on
yeah, what a price on carbon. Well, there's different ways of doing it. Basically, it means finding a way to put a cost on something that is currently free for us to do, namely pumping carbon into the atmosphere. In economics, it's called an externality, which means that in the process of using fossil fuels, we generate something that creates a problem in the world and nobody's responsible for it. So it's a cost, it's a burden on the planet that nobody pays for. And so pricing carbon means finding a way to account for the carbon that's being pumped into the atmosphere. There's different ways of doing it. One of the ways of doing it is to have, it's not that hard to actually keep track of how much oil, gas, it's well known how much oil, gas, and coal is being dug up out of the ground in the world. And it's easy to calculate how much CO2 that stuff is going to produce when it's burned. And the ideal way to do it is to put a cost at that point. So if somebody digs up X amount of coal and we know it's going to produce 100 tons of CO2, we charge them 100 times whatever the charge on a ton is. So you charge on a per ton basis of carbon dioxide that fuel will produce when it's consumed. So that's what pricing carbon is. There's a lot of different ways of doing that, but that's what it is. So I'm going to go to the detail thing. What do we think that carbon pricing is going to do? I'm going to put it up to, let's say, $50 a ton to start. What do you want me to start with? 50 sounds good? Okay, I'm going to put 50 in. I'm asking for predictions. How much do you think this will impact our temperature?
This is fine.
I'm going to put 50 in a second. I don't want to put it in until I get the prediction.
It's gonna go down 0.2.
Down 0.2. Okay, let's see. I'm going to put 50 in here. We're down 0.2.
Whoa,
I mean, good at guessing.
good guess.
I'm going to go back to the original setup, or current status quo. And the reason I want to do that is because I'm now going to put 50 in again. Went down 0.3. If I put, hmm?
Yeah, okay, yeah.
And that's a medium, that's actually a low carbon price. Companies are currently getting subsidies of $50 a ton if they find ways to remove carbon. They're not doing it because it costs a lot more than that to capture carbon. But if we bring that price up to say $100 a ton, that makes that alone changed the temperature from 3.3 to 2.8.
Can you look at economic growth based on that carbon price?
What the actual economic growth is based on it?
Like the slider didn't change on economic growth when you add carbon price.
Well, no, the sliders, when I move one slider, it doesn't change another slider, but
I
it
see.
does change what's happening in
I see.
the world.
Unless it has one of those subgraphs that talks about the effect on it.
Yeah, actually, I think I can do this. Again, every time I do this, different things come up, so I don't know where everything is. Impacts, economic, financial. Let's see, I'm trying to find where economic growth would be here. Oh, boy. Global GDP loss. So a slight decrease in global GDP with that carbon pricing. It also impacts market price of electricity. This is what happens when your carbon price goes in. Your cost of electricity goes up. So that can have a negative impact on people. So one way of easing that impact is taking the money from the carbon fees, from the pricing, and give it back to the people that need it the most. This is actually a proposal that has been in Congress several times. That's called carbon fee and dividend, where the impact, I'll come back to that at the end and we'll talk about that a little bit, but we can ease this increase in price on the people that can least afford it can be compensated for by using the money that comes from the carbon price. And I can put that much higher and it makes even bigger difference in temperature with a price of, what is that price now? $200 a ton, let's say. Right there. At some point, there's sort of a diminishing returns on that. You increase it up to a certain point, and the models doesn't give you more. So this extra cost of electricity can be mitigated by using that carbon pricing.
Now, we have an online suggestion. What if coal is decreased, but it is replaced by natural gas rather than renewables? I think that will have a big impact.
Okay. If I okay, I'm going to have to remove the carbon price though in order to do that. Because carbon price affects natural gas. Decrease coal.
Decrease coal and increase gas.
Well, the increase in gas and really, the decrease in coal, a lot of the coal does get replaced by natural gas. Right? If you look at
I'm
this,
sorry, that was in reference to the carbon tax.
Oh,
So maybe keep the carbon price up and decrease coal.
I'm gonna put carbon price up there, coal here. Now you'll notice the coal graph with that carbon pricing drops very close to zero by the end of the century. So putting further burden on coal, more taxes on it, isn't going to affect that very much. You can see, makes very little difference. If I increase natural gas, it has a small impact on the price of electricity. It has virtually no impact on the temperature. Cynthia?
How about deforestation? Like a lot of people are spending a lot of hope on that.
Okay. So this slider is about implementing policies that encourage people to keep their existing forests, to decrease the amount of deforestation that's going on around the world. Again, this is a global model, so you can't just say, stop cutting wood in Maine or something. And I'm going to move that over. What do you think is going to happen on that?
I think it depends on how far down you move it.
Okay.
Let's say if you go to the midpoint, I would guess that it's going to have I'll say a major impact. And we've been talking about 0.2 or
Okay.
0.3. So probably bring it down to, say about 0.5 or 0.6.
I'm going to go halfway.
Yeah.
Brought it down by 0.1. Now, one of the things we can look at when we look at this is greenhouse gas emissions. Instead of just net greenhouse gas emissions, you can do greenhouse gas emissions by gas. The different types of gas that are greenhouse gases. And this actually distinguishes two different sources of CO2, namely land use CO2 here, land use CO2, and fossil fuel use CO2. What it doesn't, there's also different sources of methane. Fossil fuels are a big source of methane because of leakage from natural gas wells. They're something like 30% of the methane that we put out is from leakage, and the rest is from agriculture. But it's the amount of methane that comes from fossil fuel is significant. That they don't separate those here. But look what happens when I do the deforestation. I'm going to move that slider back and forth. This is land use CO2, which includes agriculture and other things. It's not very big to begin with, so even if I remove it completely, it does not make a big difference in how much CO2 we put out. In fact, if I do this, it goes almost to zero. I'm going to do something else to make it go even smaller. I'm going to go to nature-based. And I'm going to do this. I'm going to do afforestation. In other words, planting trees as opposed to not cutting them. And so that's something you can actively do. And so I'm going to make a lot of land available for that. I'm going to start and do other things, sequester carbon in the soil, do biochar, a bunch of different ways of reducing, of taking up carbon from the atmosphere, CO2 from the atmosphere. So if I do these things, you'll notice that the green actually goes negative. In other words, we're actually removing the net amount of carbon from agriculture, from land use, actually is negative. That's a good thing. But you can't get any more than what's already there. In other words, even if we removed all of it, we'd still have all of these other greenhouse gases. There's no way to compensate for that with trees. That's what it amounts to. But we're getting down to 2.5. They're getting there. So it's pretty clear, I think, that we need the carbon tax. carbon pricing. But we're still only at 2.5. We need to get down to 2.
I mean, we're looking at this as all the way to the end of the 21st century, really,
Yeah.
2100. And to me, the real technologies that might have some kind of an impact are nuclear, and especially new zero carbon, which I assume you're thinking of fusion.
Yeah, that's what they talk about.
If those are really pushed all the way to the right, what would be the impact?
Good question.
And we're talking about by 2100. It's not going to happen tomorrow.
Right. It takes a good number of years just to build one nuclear power plant these days, and the fusion plants are.
Not yet. Dream.
It used to be that nuclear fusion was 20 years in the future. For like 60 years, nuclear fusion was 20 years in the future. With the recent advances, now my prediction is that nuclear fusion is going to be 10 years in the future for the next 30 years.
Is that what your cynical hat on?
You know me, Dan. Okay, so nuclear. I'm gonna push nuclear as hard as I can here. Again, I don't know if these policies how much they would actually. It makes a difference.
Yep.
0.1 degrees. But you can also see that it's reducing the amount of renewables that we produce. In other words, not only it's going to be replacing some of the renewables. New zero carbon. Same thing, it reduces the amount of renewables. I'm pushing both, and it doesn't make that big a difference in the end. I don't know the details behind these models, so I can't really tell you the mechanisms whereby, what are the pressures on the different parts of the system that cause it to push down renewables instead of eliminating the fossil fuels altogether. Cynthia.
So it seems if we're trying to put together a combination of policies, I feel like it would be pretty logical to do the buildings and industry,
Yes.
energy efficiency.
Right.
And so we want to add that in?
Absolutely. That's in the end, that's obvious that we need to do that.
And then there's been a lot of talk about agricultural.
And you'll notice that these things happen without a negative impact on economic growth. If you do it right. Would you say agricultural? Yes. I'm going to go to agricultural emissions. I like to go in details here because there's some really cool things. These are actually recently specifically added to the model when I use detailed settings, because people are always asking about animals. And from livestock, nitrous oxide and methane, I'm going to reduce that by 60% of its potential reduction, and from crops as well.
What crop gives off methane?
It's when they're rotting.
Stuff that rots, but it's also from fertilizers and nitrous oxide. Nitrous oxide is fairly potent. It's not as much of it, but it being more potent. The other thing that comes up here, which is on the graph, is F gases. Those are like refrigerants, and it turns out that they are the most have the most warming potential of any gases that we know of. See, everything's measured in terms of comparison to CO2. So methane is between 30 and 100 times more potent as a greenhouse gas than CO2 is, depending. 30 to 100 seems like a big range, but it depends over which time scale you're measuring. But we always measure in terms of CO2 equivalent. So if I have this much methane, we count it as this much equivalent CO2. Turns out that methane being 30 to 100, and nitrous oxide, I forget what the number is, but there's some refrigerants that are literally thousands of times more potent as greenhouse gas than carbon dioxide.
There's a freon in those things.
Freon,
Right.
and other refrigerants. And there's a thing called sulfur hexafluoride, which is the most potent greenhouse gas, which is 23,000 times more potent than CO2.
But what is the volume of those?
That's
versus
exactly the
carbon
point.
dioxide?
They're tiny, tiny volumes.
Yeah.
And sulfur hexafluoride actually has some interesting uses in energy, in switching, electric switching, and people are concerned about it. So yeah, and the other thing is food from animals. If we reduce our diet from 30% of our food coming directly from animals to, let's say, cut that to 20%, that makes a difference. You can see the decrease in the methane emissions by food from animals, if I cut that down by half, let's say. And then there's food waste. There's a huge amount of food waste. And if not properly taken care of, that doesn't make as big a difference, but it makes a difference.
What's
And we're
behind,
down to 2.2.
what's behind that food waste there? Is that if you burn it, if you, or you
A couple of
compost,
things.
if you,
One thing is that we have to produce more food if we produce more food waste. In other words, we're wasting food. We need to produce more. And then there's the emissions from landfills. They're capturing some of that, but it's not a. Yeah. Let me see.
Well, we only have 7 minutes, we have to save the world, so.
We're almost there. We've almost saved the world.
we make it down below 2. You're talking
I'm
about
going to
1.5.
electrify. I'm going to make transport more efficient. Huh? Wow. Yes. I'm going to electrify transport. Again, that makes no difference because it's happening anyway. This model has evolved over the years as projections have changed, because almost all the predictions people made a few years ago for things like the cost of solar energy have always been wrong, have always been higher than what they've actually come out to. So some of these things have actually happened faster. When I first started using this, the starting temperature here was I think 4.2, and it's down to 3.3. In other words, we've improved things already since they started using this model in the late teens. So, and now I'm going to electrify industry too. Things like manufacturing of steel is a heavy coal user right now. They make coke for conversion for making steel. Actually, that didn't change very much, but again, because we've already put a lot of pressure on coal use from these other policies, that those things are going to be electrified anyway. And now if I go to economic growth, look what happens if I decrease economic growth. Before it made a difference of 0.3 degrees, now it only makes a difference of 0.1 degrees. Because economic growth relied more heavily on fossil fuels, and now it relies less so, because we've done all of these other things.
What happens if you play with coal now?
Play with coal?
You know, like
Nothing much is going to happen, because the carbon pricing basically killed it.
Okay.
A war on coal, yes indeed.
If you take out
but-
the new zero carbon,
It doesn't change our
Doesn't
total
change
energy
anything.
use. This stayed the same, the total here. It just shifted it to renewables.
How about the waste and leakage thing? That
Oh
should
yeah,
be
we didn't get to that one
Easy to
yet.
do policy.
Waste and leakage. Let's see what that entails. Now you'll see that I haven't done anything on that slider yet, but we've already reduced that.
Oh,
How do we reduce that? By putting a price on carbon.
oh.
That reduced those outputs because it reduced the amount of fossil fuels. This black line was, a lot of that was methane from fossil fuels. It was non-CO2, it was methane from agricultural use. If we stop leakage, there's maybe not a lot more we can do, but let's see. Actually it made a significant difference, 1 degree. Every 1/10 of a degree now becomes significant. When we first started, it was like, 1/10 of a degree, we have to go down 2.5 degrees, 2.3 degrees to get to where we want. So here we are, we're getting there. 1.9. We're down below 2, yippee. We haven't done any technological CO2 removal. Technological carbon removal. There's a lot of debate about whether this is even ever going to be cost effective. because
Is
the
this
technology.
is this a technology that exists already?
There's different things that they're doing. There's carbon capture and storage, where they literally have air coming, they remove carbon dioxide from just air. It's so low density carbon dioxide is in the atmosphere that it's very expensive to do that. Then they have other things that they're making claims about it being carbon capture, where they're using at a power plant where they burn natural gas, is to remove the CO2 from the exhaust. And since the carbon dioxide there is much more concentrated, it's more cost effective. But of course, where's that carbon dioxide coming from? It's carbon from fossil fuels to begin with. So, but let's see what we can do here. Technological carbon removal. So that would be direct air carbon capture. That's what DAX is, direct air carbon capture and storage. Enhanced mineralization, and there's other technologies that people are working on. Putting lye in the ocean to make it less acidic so it'll absorb more carbon dioxide.
What could go wrong with that?
Those are sort of, what do they call
Geoengineering.
geoengineering stuff, yeah. So yeah, we can bring it down, not very much. We've used up almost all of our policies, and we're almost out of time, and we're just barely there. Economic growth doesn't seem to change it anymore. Population doesn't seem to change it anymore. Population, we can increase the population, I don't know if we want to do that, but we can increase economic growth. That increases it a tiny bit, but it means there's room for normal growth in the economic sense.
Probably not gonna affect, but try that new zero carbon stuff halfway across.
Again, that doesn't help a lot.
Nothing at all.
Increase renewable subsidies, that doesn't help a lot either.
We're doomed.
No, we got it down to 1.8. It's not awful. Another thing has changed in the model, even though when I first did this, it was like 2018, I think, when I first started using this in my classes, that starting temperature was 4.1 or 4, I can't remember exactly, but it was around 4. I could get it down to 1.5. Which means we're passing certain points where we need to be doing stuff. I didn't have to do as much carbon removal. The model has evolved some too, so maybe that's changed as well. In other words, maybe they've made some. By the way, this model has a lot of assumptions, but you can find them all if you go up here in the simulation. You can get deep inside this model if you want. You can even change some of the assumptions. What are these? What kind of assumptions are we talking about? Example, climate system sensitivity. Like how much CO2 concentration is required to produce a 1 degree temperature change. Those are, there's uncertainties, there's scientific measurements that put upper and lower limits on that. So you can actually change that. I'm not going to get into changing those assumptions right now. Once you get deep inside, yes, Cynthia?
So, is that it? Is that as far as we can get it, or is there, I'm very anxious about this. I want to see the 1.5.
Okay.
What can we do? How about nature-based? What's that?
Let me just push all the sliders all the way over. Yeah, I didn't go all the way on that. Agricultural emissions, I'm going to go all the way on that too. There we go.
Okay.
We're pretty close anyway. Pushing the carbon price higher doesn't really help because we pretty much eliminated fossil fuels.
And the economic growth?
I mean, 1.5 is not like where you're either on one side of it or the other. It's a goal,
Yeah.
but it's not a hard and fast end. So what it means in the end is we have to do everything.
Everywhere, all at once.
Everywhere, all at once.
Yeah.
And it really, but keep in mind, the single most effective thing on here is carbon pricing. With that, things will follow. And again, we have to do a lot of other things.
But
I mean, some of these other things don't make much difference now. If I remove the incentives on renewables, it doesn't change anything. If I remove electrification of cars, you're going to get electrified anyway. Yes?
Can I just tell people that there is a movement in the country, it's kind of subtle at this point, but to try to get Congress to seriously consider a federal carbon fee and dividend policy that would cover the whole country, that would give back all the proceeds of the carbon fee to American households evenly, like equally, and which would be helpful to the bottom 2/3 of earners and so on. So it's something that would have a huge effect on the economy for fossil fuels and help stimulate renewables.
Mm-hmm.
Clean energy.
I'll show a slide about that, if I may. We have a hard cutoff, John?
No.
Okay.
And in fact, Camden passed a resolution a year ago or 2 years ago, supporting that concept and sending a message to Congress that we as a town think it's a good idea. Along with 29 other folks.
So what Cynthia is talking about is a carbon fee and dividend, and here's an analysis produced this chart that if we have a carbon fee and dividend, this is in the U.S., that this is it. What is in the first years? I can't remember. Yeah. So early at a price of like $15 a ton
Right.
of carbon, that would cause prices of everything to go up. In other words, the fossil fuel companies are going to pass on their costs of $15 a ton to whoever buys the fuel. And so that'll get passed on, and then the manufacturer will have to pass that on. They'll also be incentivized to use less fossil fuels to increase their profit margins. In the end, your refrigerator is going to cost more, your car is going to cost more, it's going to cost more to heat your house, electricity is going to cost more. What do you do with that money from the carbon fee and dividend if you distribute it equally to all citizens? The poorer citizens who use less carbon, the lower income, who use less carbon, will get the same, before taxes, will get the same benefit as everybody else, and after taxes, more benefit. So these are some of the projections. Increase in costs for somebody in the lowest quintile of income would get a net benefit of $514 to cover an estimated increase in costs of stuff of $273. Net benefit, all the way up to quintile 4 when they become close to equal. And then if you're in the top quintile, or if you're in the ultra, top 1%, your carbon usage is up here for your private plane, for your yacht, for everything that you own and buy, your mansion, your lawn care, your swimming pool, whatever. Your 7 refrigerators instead of 1. You're way up here, but you still get only $383 back. So it's an equitable, it's a progressive tax.
The fifth quintile is the policymakers.
That's the problem. Anyway, okay, I think, are there any more questions from John from the chat?
No, not so
Okay.
far.
All right.
Well, that's wonderful, Paul. Thank you very, very much. Thank you for joining this Tuesday talk. For more information, please visit Mary Spring at www.maryspring.org and also